All right. Well, welcome to almost the last class of forever. Um, so Thursday, I'm just kind of planning to spend, going over whatever people want to go over, talking a little about the final exam, stuff like that. So today's kind of our last, lecture on like new material and such. So any questions anyone wants to start with?
I've got one
Go for it.
that's maybe a little pie in the sky, but I I'm curious. Um, so the way I did my PA 4 and 5, I did kind of quite a lot of shared state. So I was passing around references to my scoreboards, which stored the players' scores, and I passed around the network manager so everybody could talk to the network manager. I passed around all these references to things.
Mm-hmm.
And I want to know if that is maybe going out of favor in favor of procedural, or is that like a really big problem? I'm not quite sure what to think about it.
Yeah, I'm not sure it's a problem. Um, so when you say you passed around, do you mean like when you called methods and such?
Yes, so my game board had a reference to the network manager, so it could call a sync the game board, or sync input on the network manager, and then my JFrame could also use the network manager to call name changes, to call syncing up the names, syncing up the size of the board,
Okay.
and whatnot. So there's two things affecting the state of that class.
Right. So yeah, I think that's reasonable to have a game board, a network manager, um, whatever else the main objects are, and make those accessible to everybody. Right? You've got methods inside, right? Maybe you've got a send message method inside the net thread class, and but if as long as you use a net thread object to get to that method, I think that's nice and clean. Um, and so I think the way I did this, I haven't looked at this in a while, so this is going to be embarrassing because there's probably like no comments and short variable names. But I'm looking for a constructor here. So for example, I call game save socket thread. That was my net thread class, right? So I pass that to my game object, which was my panel, so that it has access to that object. And then when it wants to send a message, it calls, whatever I save that as, socket thread dot method name. Um, And when I construct the socket thread, I give it the name of the JFrame and the name of the JPanel, and also a tag to tell it if it's a server or the client. But then, the net thread has access to the JFrame, where it can get to, the main pieces that were available there, the text fields for score and name and so on and so forth. And you get to the game, which I think is where I put the mouse click code. Um, but I think that's a reasonably clean approach. Um, I'm not sure I know of a different way to do it that would be cleaner.
So I ended up using a bunch of, I guess, static members and methods, and then making those publicly accessible to do the updates and stuff. And so I did a lot of my, I guess, calculations and stuff kind of in the socket thread.
Okay. So the potential thing when you start making lots of statics is that maybe what you're doing is you're basically implementing like global variables. And so maybe we keep, the player scores in a global variable, and we can access it from different locations. You can make that work, but it doesn't feel quite as sort of object oriented focused. You could instead think of, what is the object that maintains the score, and that's the thing that's responsible for maintaining, and then all the code that manipulates the score is inside that, and then when anybody else wants to change the score, check the score, reset the score, right, they do it through methods in that particular class.
Okay.
You could. Mine was in effect a singleton, but you could make it a hard singleton where there's static methods to interact with the actual object, like getting a reference, invoking the private constructor, and so on and so forth, to keep yourself from making a bunch of problems if you reinstantiate it.
Right.
But I almost did exactly what you were describing, because I wasn't sure if I had a running thread, I could still invoke methods on it from the main thread.
Yeah, you should be able to.
Yeah, you were able to. One thing I kind of want to try, or I was considering trying, was doing multiple inheritance. So,
Okay.
what if I could have like the network manager also be a JLabel that has information that it will display to the user, like somebody's connected, somebody is not connected. But it's also implementing a thread, or inheriting a thread. One thing I want to try is I want to make it a JLabel and then have it implement the interface of runnable.
Oh, interesting. Yeah, we didn't get to implement runnable, but that's the other way to make a thread when you don't want to or can't extend. And it's the same thing. You just make a class that implements runnable, and you write a run method.
Are we going to talk about interfaces a little bit?
I don't think we're going to get into that. Well, I'm going to talk about Android, and we'll see an interface in there. So yeah, maybe we'll touch on it a little bit today. Yeah. One thing to let your minds drift to sometimes when you're thinking about how to structure a project with a bunch of classes, right? So in this PA5, we had a single server that would run its server side, and a single client that would connect to it. But what if you wanted to make a server that would let two people come in and say, hey, we want to play a game together, and it would create a server version for one of them and a client version for the other and connect them together. And so if you imagine, if your main frame is called, NetDot, would it cause any problems if you had 100 instances of NetDot, right? If you constructed 100 different NetDot objects. And this is where, if you're using like statics, for example, you can start to see some potential issues, because maybe there's only one, whose turn is it variable. And if that's declared statically as part of a class, you couldn't have, multiple versions of NetDot objects running. They would all be using that same static field. And that wasn't a consideration in this case, but it's something to think about in general. When you're defining a class, am I making this a class that can only be constructed once, or could it be existing in several different instances simultaneously and still working fine?
Yeah, it felt really uncomfortable to make so many static variables and classes or methods, honestly. So I knew that it would work in this instance, but yeah, it just it didn't feel right.
But that's part of the goal of this, right? I had almost no requirements on how this was structured, other than I wanted the main class called NetDot, and probably about a quarter of the people did not do that. I didn't take off points, but other than that, I had no real requirements on what you called your classes, how you structured it, where you put things, and that was deliberate, right? It's because I want people to explore and figure out what makes sense for them.
That's funny. I almost crashed my whole program because I went back to look at the requirements.
Yeah.
And I saw that it was net dot, net dots. and I had originally named it net dot, so I had to go back through all my code, delete the S's, create a
Oh.
new class, and copy and paste, and all. It was fun.
Oh yeah, totally.
I just realized that I called it dots and didn't realize it was singular.
Yeah, I mean, that's not like a galaxy-ending event, but let me mention something in here. There's a lot of Eclipse we didn't get to, and most of it, you can live without. But refactoring is a good thing to know about. So. I've only got one class here, so this isn't terribly interesting. Let's say I want to change my linked list name instead of history to be, pages or something like that, right? I don't want to just blindly go through and change history everywhere because, that's going to affect other things that might have the word history in it. And so I can, let's see if I can do this. I can say refactor and rename and press enter to refactor. And there's options. I'm just going to press enter. Oh, maybe I wanted options. Anyway, refactoring is the way that you can do things like change a name in a reasonable setting. So here's a new name for history. I can call it pages, and it will do more than just blindly go through and look for this pattern and replace it with that pattern. So it understands, if this is a class, it has to update the class definitions and so on and so forth. And usually this will do the right thing. And so it looked like it did that without causing any havoc.
Usually saves you some more pain than Control F,
Totally.
which can sometimes mess things up, but sometimes it's also good to use Control F.
Yeah, if you want
have
excitement.
other options.
It's a lot more fun.
I feel like hitting Control Z on everything.
Oh yeah.
I've noticed the diff capabilities of this Eclipse are pretty good too.
Mm-hmm.
So,
Yeah, so Eclipse can do a lot. All IDEs can do a lot to actually help you with development if you take the time to learn it. So you can do version control. You can compare changes. So if you try to compile your code and you're getting a bunch of errors, you changed one thing and it just broke 100 lines of your code. You can do a comparison and say, oh, I used to have a curly bracket here and now I have 2 curly brackets. Stuff like that.
Get stuff to format your code,
Mm-hmm.
help you code in other languages, debuggers.
Iron your shirts for you.
wait, I didn't find that feature. Where is that?
It's under the wardrobe option.
Okay. Hey. Totally missed it. Alright.
All right. Other questions, comments, thoughts? All right. Well, so I'm going to talk about Android, and it's not part of the course outcomes for this class per se, but Android Android development is an area that is easily accessible. Right, it's free. You don't need, to buy anything or get a license or anything like that. You can develop on virtual devices, but you can also go to, Walgreens and buy an Android phone, and it'll set you back 20 or 30 bucks maybe, right? And you don't need to get a SIM card and pay monthly plans and all that. You can just use these devices as smart Wi-Fi devices. And even an inexpensive phone will, you usually have a GPS inside, probably Bluetooth, wireless connectivity, ability to go to an app store and download all kinds of pre-built software. And it's just this great little platform, right? It's in some ways more powerful than a laptop because it's got all this other stuff inside, all this other hardware, tilt sensors, accelerometers, things like that. But you can write your own apps for this, and you can write them in Java. And so a lot of what we've done this quarter carries over very nicely to Android development. And yeah, if you don't want to buy a device, you can use a virtual device. So there's an Android Virtual Device Manager, AVD, that we'll look at, that lets you, pretend, okay, I'm going to develop apps for a Pixel 3, and it'll give you a virtual phone that you can interact with. And so this is just kind of an example of, an ecosystem of hardware and software and an operating system and an environment that you can use what you've been doing this quarter in to develop apps to control these portable platforms with all this cool hardware inside. And you don't need to deal with a Play Store or anything like that. You can just write an app and dump it onto your device and use it. And if it's a Wi-Fi based thing, it'll use the Wi-Fi radio inside the device and so on and so forth. So it's a pretty low cost of entry in terms of actual cost, but also in terms of what it takes to get to the point where you can develop. But there's a big asterisk next to that statement. So all of these things are moving targets. So I did some Android work about 6 months ago. And I knew I'd be probably lecturing on this in June. So I made careful notes. And I got down my tool chain and I did examples and all of this stuff. So Sunday I decided, okay, I'm going to talk on Android next week. I pulled out my notes, I started going through them and trying to replicate them, and it did not work. Because things had changed. And this happens, this is good and bad, right? So I spent a bunch of hours on Sunday refiguring out, how to do the things that I wanted to do, and reading Stack Overflow and listening to people complain about, how this changed and it makes no sense and so on and so forth. But by Sunday night I had, a new set of instructions, a new set of demos I was planning to go through and so on and so forth. And then yesterday, in the other section of 223, I started going through that, and it didn't work because something had updated. So this is a moving target, and it's kind of the nature of a lot of sort of modern environments, that things change all the time, and people are less and less concerned about backwards compatibility. I think the opinion is, if you're doing development, you're going to keep up with the updates, you're going to read the release notes, you're going to go to the conferences where they talk about, this major update that's coming out, and so on and so forth. And that's great if that's your job. It can be frustrating if you're just, I just got a great idea for an Android app. I'm going to fire this off at lunch because I got a free half hour, right? Probably not going to work. But if you keep up with it, it's pretty good. Speaking of updates, happy Corn Mob Day. Whoa. So, happy Corn Mob Day.
Hold on, I gotta go look that up.
Nah, it's not a thing. Well, maybe it is. Minecraft? Yeah, so they came out with 1.19 today, and there's been much anticipation in the house. But somewhere along the way, we started a rumor that corn was going to be a thing, and then I started a rumor that there were going to be corn mobs, and they were going to push you into fire and then put butter on you and stuff like that. So we've been counting down to Corn Mob Day, which is today. But there are tadpoles, so that's cool.
That's awesome.
Yeah. All right, so Android's a moving target, and I got this stuff working last night. We'll see if it works today. I did not do any updates, but things update in the background sometimes, and so this is part of what happens. So let's let's run this and see what happens. So I have already downloaded this and made a shortcut to the binary, and this is running on Linux. And this seems to work a little better in Linux than Windows. I've done it side by side, and on Windows it feels like it's a lot slower. But whichever platform, it's a lot better than it used to be. Not so long ago, Android development was done under Eclipse with a plugin, and that was a dog. That was slow and buggy, and just all around painful. And now they're built on top of IntelliJ, and it seems to work pretty well. So you start off with a splash screen, something like this, right? I'm just going to say start a new Android Studio project. And the project I'm going to go with is an empty activity that has the minimal amount of stuff. It's basically a hello world. So I'm just going to say empty activity, and next, and I'll put in my name for my project, so I'll just say test 31. Packages we didn't get to talking about much, but a package is basically a way to describe a directory tree under which your classes are going to be placed. So my classes are going to be under a subdirectory called com/cellmatrix/test31. And packages let you have multiple classes with the same name, but they're in a different namespace basically, so they don't conflict with one another. Save location. First time you do this, pick a root directory for all of your projects, and each project goes in its own subdirectory with a ton of files that will be created. And language, you can do Java or Kotlin. Kotlin is Java-like, but with softer typing and some other things that some people prefer. I've done some Kotlin development. I found it kind of frustrating because it's making some assumptions for you, and if you don't know what those are, which I didn't at the time, that can be extra confusing. So I'm just going to go with Java, and this is a Java class, so why not? Yeah, go ahead.
Can you use other stuff like Scala?
Not in here, but I'm guessing there's probably like plugins or other IDEs completely that you could use.
Gotcha.
So you can also pick which software development kit you want to use. So, Android has been out for many years, well over a decade, probably closer to 2. And so different versions of the API. And the newer the version, the fewer devices will support it. So I'm just going with Android 8, which was called Oreo. And it says, 86% of devices will run that. And it doesn't break my code. If I change this, things start to break. Unless I download, different packages and updates and so on. So I'm just sticking with this for no particular reason. And I'll say finish. And you get a window like this.
This is IntelliJ, right?
This is IntelliJ under the hood, yeah.
Nice.
Although I've got a VI wrapper on top of it, so I can at least, edit.
It looks like Writer, which I've also used, and these guys also make.
Cool. So you open this up. You gotta wait a few minutes because it's doing stuff.
Wow, that's chunky.
Yeah. Alright, so up here, it says Pixel 3 API 28. You can run a device manager that will let you create a virtual device, and you can choose, pre-configured devices, and you can specify how much memory it has, and so on and so forth. And you can develop for phones, smart TVs, watches, tablets, and so on and so forth. So I've already got a virtual device for Pixel 3, so I'm going to go ahead and start that. And we'll play with a real device instead, but this is freaky enough that you want to at least look at it. So this giant thing popped up on my other window. It's bigger than 1080 pixels. But this is a virtual Pixel 3 phone. know if it's up or not.
It's like the build now.
There we go.
Okay.
All right. So this is a typical Android phone, and you know, it's got the date and the time and battery life and the Wi-Fi signal and all that kind of stuff. And it's a full-fledged emulation, right? I can bring up a browser and you know, put in a website, and you know, that's all like stuff. I haven't tried making phone calls on here, but that would seriously freak me out if it worked. But most of this other stuff works. And you know, you can go to the Play Store, so it's piggybacked on top of my Wi-Fi. And if I sign in, it would let me get to the store and actually download stuff and so on. So that's pretty cool. And I wanted to do just a hello world, but I'm getting these Android resource linking failed. This was the error that popped up yesterday in class. And if you Google this, right, I mean, this was back in 2018, but this is a recurring thing. You know, it can also appear if you have this, according to the above error, this solved my problem, Mother of God, mine was actually this, mine was this, +1 for saving me time. What's most annoying is that Studio's pointing you to the wrong file. And so, you know, you go through this, and it's like there's millions of different causes. Thank you, you saved us. Thanks, you saved my day. Can't believe the solution was so simple. All it took was a copy-paste to those two Gradle files. But none of this stuff is straightforward or reasonable, right? So here's the fix that I figured out from all of that, because I'm getting this, you know, stuff down here, and if I try to build, I get these mysterious errors that seem to have, you know, something to do with this line here, but really don't. So this is just for me. If you download a fresh version of Studio, it may work great. But I'm going to go to build.gradle. No, I'm not. I'm going to go to build, and I'm going to do edit libraries and dependencies. And this is the thing that just updated a couple of days ago, was this app compat. And so instead of 1.4.2, I'm going to roll this back to 1.3.1. This is the kind.
Does this compile to native code, or is it run like on top of a JVM or something like that?
It's almost certainly compiling to bytecode and running on top of a JVM.
Ah, okay.
Yeah. So I'm rolling back ActCompat to 1.3.1, and I'm rolling back constraint layout to 2.1.0. This is the stuff that makes you question why you're studying computer science. But it works, and it gets rid of that. And so now I can go ahead and say, let's run this. And give it a minute. It's building, configuring projects, build successful. Come on. There we go. All right, so there's our test 31 project. It's just a hello world, right? But that, you know, gets it from all of this stuff onto this virtual device. So that's moderately exciting. Let's go ahead and shut this down, and let's fire up the amazing Amazon tablet. So this is a kind of generic tablet that I picked up from Amazon before spring, because I thought I was going to be in person and I needed to be able to, you know, cheat and look at my notes when I'm lecturing. And so I've got this connected with a USB cable into my my laptop, and once it boots up, we will go ahead and configure this so that we can actually download stuff onto here. So, do my super secret unlock code, which you can't see by looking at my finger marks. Alright, so first thing you need to do is become a developer, right? So on some systems you have to, fill out applications and send money and wait and stuff like that. Becoming a developer on Android is super easy. Go to your settings, and then come down to About, and come down to Build Number, and click on Build Number a bunch of times. So I'm just going to click a bunch of times, and now it says you're 3 steps away from being a developer. So click it 3 more times and 1 more click, and bingo, you're a developer. So confirm your pattern, and there you go, you're now a developer. You're done. Alright, so so that allows you to turn on developer options. So next thing is go to System and go to Advanced and Developer Options, and just slide this box on to say Developer Options. That's already on. And I'm going to turn on USB debugging so that I can go through my USB cable and load code into here and see what's going on. So I'm going to flip that switch, and it'll ask if I want to allow this, and I'll say yes. Now, I've done this before on this tablet, but normally the first time that you do this, when you try to connect from something like Studio, you'll get a pop-up saying, hey, somebody with this fingerprint is trying to connect as a developer. Do you want to allow this? And you can say yes, and it's just a security thing. Alright, so let's go back home, and let's come back over here. And so when we did that, we got a new option up here, which is the Shenzhen Yidong Technology Company Limited CP10. That's this tablet. So now I can take this code and just hit the play button to download it onto the tablet. And wait for it. Still waiting for it. Oh man, it's bumming me out.
Somewhat unrelated.
Yeah, go ahead.
Do you know any good strategies for how to get Rider and IntelliJ super cheap? Any the JetBrains products?
IntelliJ is free if you're doing it for like non-commercial.
Oh yeah?
At least last time I looked, they have a free version. Alright, there we go. So that's running, and there's our hello world, and that's test 31. So you can develop on a virtual device, but you can also push over to physical hardware, and it works just the same. And I can just drag my icon over here, and now I can pop my app up whenever I want. Alright, so that's logistics of getting things up and running. So let's look at app development. And I don't know, I don't like seeing all these red marks over here indicating problems, but cannot resolve symbol, whatever. All right, so let's take some of the stuff we've been doing with Swing and Window Builder and do that over here. So I'm going to close out this tab. So I'm going to go to App, I'm going to go to Resources, I'm going to go to Layout, and I'm going to open activity main.xml. And I'm going to wait a bit. I'm going to close this thing out. And so this is the picture of my Pixel. I should change this to a tablet, but this is what the Pixel phone looks like, right? And we've got, our window of different widgets. We've got text views, buttons, image views. We've got different text objects, plain text, password fields, and so on. We've got different types of buttons, radio buttons, checkboxes, and things like that. And theoretically, you can take these things and drop them into here, and design your GUI. But that's the thing that stopped working Sunday when I tried this, and it had been a few months. So the issue here is window managers, right? So we mentioned in Eclipse with Swing, there's default window managers that will control where your components are on a panel or a frame. And we disabled that by saying, let's do an absolute layout. So if I place a button right here, the button will be there. If I place a text field over here, the text field will be over there. As far as I can tell, there is absolutely no way to do that in Android. And people think this is a feature. So here's a workaround. I'm going to go to Constrain Layout. I'm going to right-click. I'm going to say Convert View. And I'm going to change this to Relative Layout. This is deprecated, but it works for now. So now, if I look up here, I can see this hello world sitting up here in the upper left. Now when I run this, it ended up in the middle of the window. That's the window manager, right, controlling where it is. So I can place this if I do the following. I'm going to click on this object, and I get these 4 little anchor points here. I'm going to click on this left anchor, get an arrow, and connect it to the left edge. Click on the top anchor, get an arrow, connect it to the top edge. And now I can place this exactly where I want. That didn't work. I can move this around exactly where I want, and that's where it's going to end up. So if I put this, part way down and kind of close to the left, and I say go ahead and run that, then it should end up, somewhere around here. All right, so there's my hello world. So this is the closest we can get to an absolute layout, and we're not trying to make an app here that will work on every device ever created. We're just trying to get a high-level overview of placing components, connecting actions to events, to code, and so on and so forth. So I'm going to have a text field up here, and this text field doesn't have a name right now. I'm going to set the name to just message box. And I'm going to take a button, and it'll be just, a plain toggle button. And I'm going to put that down underneath my text field. Now, again, that got anchored to the upper left corner, so I'm going to do my same trick again. And put these anchor points here, and now I can move this down below. And now if I run this, I should get a window with a button and a text field that says hello. So there we go. And the button doesn't do anything. It would be kind of disturbing if it did. All right. So this is perhaps similar to what we've been doing in Window Builder, except in Window Builder, when you do these things, when you place components, when you move them, it generates Java code that basically calls methods from these components and sets up values for, dimensions and location and so on and so forth. In here, when I make these changes, what I'm doing is I'm actually editing XML code. So XML is a markup language. It's kind of a generic extensible. That's the X markup language. So it's just a file with a bunch of tags and end tags, and you can put whatever you want inside these tags. And so when I dropped that text view, when I dropped that button, right, it made a entry in my XML file saying, okay, here's a description of a button. The name of it is button, that's its ID. Here's where it's anchored relative to the start and the top, 52 and 171, which is this 52 and this 171. And if I move it somewhere else, like 158 and 156, right? Those dimensions have changed, those locations. And the text, says what should I display inside that button. Well, I can change the name of this, the text here to like, go. And now if I look at the XML, you can see the text is equal to go. So this is a little more data driven than we're usually seeing in Android in Eclipse, for example, with Window Builder and the stuff we've been doing. This information is used by other methods to figure out, where to place these objects and what dimensions they should be and what should be displayed inside here, and eventually what should happen when this button is clicked, and so on and so forth. It's linked through these XML files. So that's a little bit of a different mindset. Okay, this is a good time to mention another difference from what we've been doing. So most of the programs we've written, either in C or Java or whatever, they have a very simple lifestyle. You do something to say, I want to run this program, and the program begins executing. Its code gets loaded into a section of memory. The CPU's program counter is pointed to, where that code begins or to something that calls that code, and your program executes. And if your program exits at some point, the program is done and the program counter goes back to where it was, somewhere in the operating system, and life continues. With Android, it's a very different kind of experience for an app. So when you click on an icon, right, your activity is launched. There's a series of methods that are called onCreate, onStart, onResume, and following those, the activity is in its running state. And that's when it's got control of the foreground of the display, so you're looking at, whatever it's displaying. But you can pause it, so you could hit the home button, for example, and that does not close your activity. It simply gives something else access to the display, so the activity is no longer visible, and the stop method might be called. And then at some point, the person might, re-click on the icon, and it goes back up and recalls onStart, onResume. But your activity, your app, is still very much alive during this. So you can run a program by clicking on its icon, and then if you click away, if you go home or you click some other icon, that first app is not exited, right? It may exit at some point, right? If it finishes, or if the system decides to destroy it, it may go away. But all of these apps are, in some sense, potentially simultaneously still running, just in different states. And so if you don't understand this, a lot of what you read in the documentation doesn't make a lot of sense. So that's something else we'll want to keep in mind.
I kind of thought that was super cool about Swing, even though it's kind of old. It just generates pretty editable, easy to read code.
Mm-hmm. Yeah, I mean, it's really doing what we would do if we had the muscle memory for, defining mouse listeners and constructing J-frames and so on. It's not really shifting paradigms on us. It's just writing the code that we might write ourselves, and I kind of like that. This is a very different kind of not in Kansas anymore sort of experience.
Yeah. And, sometimes when I'm writing HTML, it's really confusing to know exactly what tags to use and when.
Mm-hmm.
It's just pretty simple in Swing.
Yeah. All right, so log messages. So we don't really have a console here, right? If I run an application, there's no console I can type things into in general, unless I do a lot of work. But this tablet is connected through a USB cable, right, to my laptop where I'm running Studio, and so there's an ability to swap information between the tablet and this tool. And so if I come down to this logcat tab and I say no filters, I'm seeing a bunch of log messages coming out here. This is what's going on inside my tablet right now. Now I'm not doing anything on my tablet, but there's power checks going on, and there's watchdogs running, and there's things that are checking the Wi-Fi status, and so on and so forth. There's all this stuff taking place in the background. And if I start my Test 31 app, I saw Test 31 fly by up here. So grallic register buffer HND, whatever that is, right? And so this can be useful, and we can filter this. We can say show only the selected application, and we can choose, do we want to see all messages, debug messages, info messages, and so on and so forth. So I can close that app on my tablet, and I can rerun it, and see messages coming out from that COM cell matrix Test 31. So I can display messages in here using a method from the log class. So for example, when I create, maybe I want, so here's the onCreate method, right? So that's that thing in the beginning of the life cycle, and I could do something like this. Log.i, so I is for information. And I can say I'm generating a message with a tag of test3. And I can say this is a test. And if I run this, I have to import. So another thing, right? I'm gonna rely really heavily on what the IDE is doing for me here, because I don't do Android development regularly. I don't know where all of these classes come from. I don't know what packages they're in, so I don't know what to import. I don't know the sort of templates for different kinds of listeners and so on. So I'm going to rely heavily on the IDE and do things like that to automatically import. So over here, if I go to my logcat, there's my information message from test 3 saying this is a test, ha ha ha. So this is useful for debugging, right? It's a way to get a message or some other information out of your code in a way that you can look at it and you can filter it and so on and so forth. All right, well, we also have a message box. So if I go back here, oh yeah, so this other thing that took forever to figure out at first. If you want to switch from the XML view to the actual graphical view, it's this little button up here that has nothing on it except, I think, a pair of mountains. So click on that. That shows you the graphical view. This shows you the XML, and this is a split view that shows you both. So we can go back and forth like that. So let's look at this text view, right? I named this message box, and I'd like to display some text in there. Now, right now, it says "Hello World" because that's the text that's inside here. But maybe I want to display something else. So this is a text view, and developer.android.com is a good website, and if you just Google Android SDK, that's the first site that comes up. and you can search for, say, text view. And this will tell me about my text view class. So, and we can look in Kotlin or in Java, so I'm going to view this in Java. So public class text view extends this, implements this, and you can read about the different. So here's all the attributes you can set up in the XML description of it that show the ID and the text and so on and so forth. And then you can find ways to construct it and then different methods. So, you know, the same information we've been doing with Oracle documentation on their packages, but slightly different format. So there's a set text method, right? We're barely through this page. So there's set text, and we can give it a string or character sequence and display the text. So what I'd like to do is when I run my code, I would like to say, you know, set the text in that message box, that text view. But I don't have access to message box here, right? It's not constructed in code. It's something that exists inside this XML. There's a text view called message box. So I need to get access to this through the XML. And so we have a method that we're going to use a lot, which is called findViewById. So let's set this up. So I'm going to make a field up here called message box, and that's going to be a text view. We'll use that to display some info. I'll import the text view class. So let's find the message box. So I'm going to say message box equals findViewById. All right, and so the argument I'm going to put in here is r.id dot, and then the name of the object. So I can say message box, and that happens to translate to this integer value, right? So this is a tag that uniquely identifies this particular object. But instead of hardwiring a magic number, I'm using this r.id.messageBox. And once this executes, this object, which is a text view, corresponds to this widget right here. So now I should be able to say something like messagebox.setText. I'm changing the text from inside some code. I gotta make this box bigger. Oh, I just made it super skinny. Alright, there's a big old message box. Alright, so let's run this. So I keep hitting the stop button, and then this, and when I ask it to run, it'll go ahead and rebuild it. Right, and so I'm changing the text from inside some code. I misspelled some. So we can get to our objects by using this findViewById. And so let's tie in the button, and then we'll go ahead and take a break. But this will give us kind of the complete starting set of things we need to do whatever we want to do. So this will give us our access to our objects and also a way to respond to events. So let's come back here and let's look at our button. And our button is just called button. I'm going to call this button, I don't I'll call it go. Right? Remember, all that that's doing is changing this ID tag to say, hey, you know, the ID of this thing is go. But then I can you know, find it by saying findViewById r dot id dot go. All right, so there's an option here for onClick, and this will let me specify a method that should be called when this button gets clicked. Well, I don't have any options in the drop-down field right now, but I can make a callable method. So let's call this when the button is clicked. So I'm going to make this public void. I'll just call it my click code. And the signature has to be it returns void, and it takes a single argument of type view. So we'll import view. And as soon as I've done that, if I come back here and I look at onClick, I have the option of saying, hey, call my click code. So it'll look for any method in my main class that has that signature, and make that an option. So now when I click, my click code should be called, and let's change our message box. And we'll just say click detected. Alright, so let's go ahead and run this. And then we'll take a break. Alright, so there's the text field that came up from this line up here, which said this is a test. And I'm changing the text. And now if I hit the go button, it says click detected. Alright, at this point, great excitement erupts, because now we have the ability to take everything we know about Java and use that inside Android. Right? If we can respond to events, if we can access objects and change their properties and so on, we're back to where we were, you know, when we first learned Window Builder and Swing. Different names of classes for these widgets, slightly different way of hooking things together, but you know, you could take your dots program and port it to Android with most of what you know right now.
You could probably even do like a direct port if you have support for AWT.
Mm-hmm.
I think it is.
Yeah.
All that stuff.
Now the painting gets a little weird.
Yeah.
But you know, painting is always kind of a strange business, because we can't paint. We can make a paint method and we can say repaint. And there's a different name for the paint method here. And you have to make a canvas instead of a JPanel. But again, it's a parallel structure. And so what we've done will help. Alright, let's go ahead and take a 5-minute break. And let's come back at a little over 5 minutes. And then we'll dig into this a little further and play around with some other stuff. All right. So, one thing to keep in mind is that, even though we've got all of this different, I would say bizarre infrastructure and these XML files and so on, this is still just Java. And to the degree that you know how to do things in Java, right, you can do things in here. And so, for example, let's just make a count. We'll take an integer count, we'll initialize it to 0 every time that, I meant to do this down here, every time that the button is clicked. Let's increment count and change our message box to say count equals and show us what the new count is. Right, so let's go ahead and put that on the device. And so every time I click this, it increments our count. So if that was like PA6, we'd be done. All right, so this is where we can start to see a little bit of this lifecycle business. So I can hit this button to go home, which, appears to close out my application. If I go ahead and I run test 31, my count is still at 10, right? It remembers that value. If I close this out again when it was 12, and I run this again, it's still at 12. If I open up a PDF file.
Isn't it basically minimizing the application, though?
In some sense, but not exactly. Some things will keep happening, some things won't. If I come back in a few hours and I've done a lot of other stuff, this will actually be reset to 0. It may get destroyed at some point. And if I do everybody's favorite thing, which is, swipe this away, and then go ahead and run this, that will reset it, because that actually caused it to be destroyed. All right, so this is all just Java. All right, another useful thing to know here is toast. So toast is how you make a pop-up. It's a bad joke. I didn't invent it. So let's make a pop-up inside here.
Not gonna lie, I just got that.
Okay. So if count is a multiple of 5, we're going to do a pop-up. So I'm going to say toast dot make text, and let me go ahead and I'll import it later. All right, so I need a context, so I'm going to do get application context. And then the message that I want to display, which will just be, I'll just say yay. And then how long I want to display the message. So I'm going to use a static from the toast class. I'm going to say toast.length_short. And this is going to be an object, and I'm going to call it show method. And I'll import toast. And this is not something that has any meaning to, people who do this, or at least to me, right? This is something that you find an example and you use it. So if I really wanted to understand, application contexts, this would make sense to me, and I would know why I was doing this and what it means and so on. But, honestly, I don't. I wanted to make a pop-up, and I found this, and I tried it, and it worked. And this makes sense to me. This is the length, and if I want to know my options, right, I can just come back in here, and after toast I can hit a period, and I can see, oh, length_long, length_short. Those are different options I have. And it's actually showing me these things are integers. Length underscore long is the integer 1, short is 0. So instead of saying length underscore short, I could just say 0. But that's a magic number, right? That's what I keep talking about in class when I say avoid magic numbers, right? In this case, right now, in June 2022, if I put a 0 in this argument, that means let's use a short length message. And if I do a 1, that'll be long. But I don't want to have all these zeros and ones sitting around, so I use this symbol, right? And this is just a static field inside the toast class. All right, so let's run this. I will eat some salad. Uh-oh.
That's such a strangely specific class.
Yeah, right?
It's awesome.
You still have to match your curly braces. Even in studio. Alright, so there's our app, and I can hit go and count as 1, 2, 3, 4. And then if I hit it once more, I get my little pop-up message that says yay for a short period of time and then goes away. And if I do this really fast, I can get multiple ones to pop up. And they'll fade out, and there's 25. So that's another way to display a message that will just kind of pop up in the middle of your window. And so that's another nice output / debugging option. All right, questions so far? This stuff is not on the exam. This is purely for, entertainment and education, and a little bit of a sense of payoff maybe for sticking out 10 weeks of this stuff.
It's pretty cool.
Cool.
Yeah, it's definitely interesting.
I think it's fun to play with, and like I say, these devices are so affordable, so available, and they work, and you can imagine all kinds of things to do with this, right? If you want to put your lawnmower on the web and do something related to that, right? Maybe you can write an Android app and just duct tape a tablet on top of your mower, and you're done. So let's take a look at GPS as an example of tapping into more of the hardware inside. And this will get us further into this mindset of how this is different from what we might do, say, in a C program. So if you've done like Android Arduino development, you know that Arduino, well, how many people have played with Arduino?
I have, but it's been kind of tricky because mine's very old and has the serial interface.
Mm-hmm. Let me grab something here.
It's just a lot nicer to use Android devices that are ready-made with all these tools and build like a Raspberry Pi or that.
Yeah.
With all these parts and pieces, and then design the case around that.
Right. So yeah, Arduinos are these little single board microcontrollers. And they're different from Raspberry Pis, which are actually like, a full-blown Linux system. They're also a lot cheaper. They're a few bucks. And this is a ATmega 328 processor. It's a little 8-bit processor. It's similar to the PIC that we use in Engineering 270. You can dump code into it, and it'll remember the code. When you power it up, it'll start executing. But it has all of these access points on the side that you can use to connect to different devices, switches and sensors and so on. And it comes in different form factors. I'm occluding my view here. So there's kind of the standard workhorse. That's an Uno, but it comes in different form factors. This is a Nano. And these chips went out of stock several months ago with a roughly 18-month expectation for when they'd be available again. So I found a manufacturer on Amazon that sold these boards for about $2 a piece, and I bought like 100 of them and just desoldered the chips. That was my inventory supply problem. But you can use these for all kinds of things. So this is that Minecraft control box for changing the time and the weather. And you know, it's just a board, and I'm just picking up 2 switches and doing some serial communication through a USB port. But these are nice devices if you have something pretty simple that you want to do that involves, you know, talking to, say, an accelerometer or a compass or things like that. So ESP32s are similar to this single board systems, but they're Wi-Fi enabled and super powerful. And again, you know, they cost a few bucks, like $3 or $4 for some of them. And so for microcontrollers, these are really nice options. But if you want something like a microcomputer, something with, you know, a whole operating system and multiple things running, that's when these kinds of devices become really attractive. And the fact that these are, you know, automatically Wi-Fi enabled, and if you have a SIM card or you have the right software, you know, you can send text messages, receive text messages, and so these theoretically work, you know, worldwide, anywhere that there's Wi-Fi coverage at least, which is coming, right? Eventually global coverage of the planet with Wi-Fi will probably be here in a few years. So these are fun toys to play with. And so let's just take a look at if we wanted to tap into, say, the GPS module on this. And this is another one of these things where there may be multiple applications running that want to use the GPS, right? I might be doing navigation with maps, and I might have you know, something running in the background checking for COVID contacts, and that wants to keep track of my location. And we're going to take our Test 31 program and add some GPS code to that. So I can't just say, you know, hey, GPS unit, take a reading and tell me your location, because it's a shared resource. And so, like most things, this is going to be event driven. And basically we're going to do 2 things. We're going to first register ourselves as a listener, just like our mouse listener or our resize listener from Swing. We're going to register as a location listener and say, when the location changes, let me know. And then we're going to write some code that will be called when these kinds of events occur, and we can do what we want in that code. And this is also going to let us look at an example of what's called an interface. And this will also let us look deeper at what happens when you write code without really knowing what you're doing. That would be me right now. And the IDE will make up for that lack of understanding on my part, because it will basically you know, do what a tutor might do if I was trying to write this and I didn't know all the details. It would say, oh, here, let me write that for you, you know. Oh, go ahead and fill in your stuff over here. So let's play with GPS. So we're going to do this mostly in our Java code. And the idea is, so when we create our application, we're going to do some GPS stuff. Alright, so first thing I'm going to do is I'm going to make what's called a location manager. So I'm going to make a location manager called LM. That's just location manager. I'll import that class, and I'm going to put this up in the top of my class. And I'm going to construct it here in my onCreate method. I'm going to say LM equals and I'm going to say this dot get system context, get system service. So this is a method that's available inside this class that I'm building. And the argument I'm going to give it is context dot location service. Alright, so I have to import context. And if I hover over this, it'll say incompatible types. I need a location manager and I found an object. So what does that mean? I'm trying to take this thing and I'm trying to set LM equal to it. Well, LM is an object of type location manager, and it's saying this thing is not an object of type location manager, this is an object. Right? Java.language.object. Why? Because this is a general method I can call to get different pieces of information about my current context. And sometimes I'm going to get a location manager, sometimes I might get something else. So this method is declared with a signature that returns an object, but I'm trying to stuff that into something that expects a location manager. So this is where we do casting. I'm going to add a tag in here. And this name of a class inside parentheses says, hey, take this thing that comes after this and treat it as if it's a location manager. So that's casting it, and it's mostly just a trick to keep the compiler happy. The compiler, part of its job is to say, hey, you're trying to do something that's not kosher. You're trying to take an object and put it into a location manager. So this is telling the compiler, I understand this is an object. Change it to a location manager and put that in to LM. Alright, so we've got this location manager. We can read the documentation of that on developer Android.com. But it's a thing related to trying to find your location. And it's a thing that in particular has a method called request location updates. And we have to say what kind of updates we want. So there's 4 arguments we're going to put into this. Again, this is not anything that you would know just, waking up in the morning saying I'm going to write some GPS code. This is stuff you have to read the documentation or find some sample code and or do a lot of trial and error. So for this, my first argument is going to be location manager dot network provider. I don't know for sure that I have a GPS in this tablet, but it will find location using Wi-Fi signals and sort of guessing my location from that. But I think there is a GPS actually. At least it gives me a really accurate number. All right, so this is the type of location information I want. This next argument is the minimum update time in milliseconds. So I want an update with a minimum of 5 seconds update. And this next is how far of a change in position constitutes an update. So a minimum of 10 meters. And then this last thing is the name of the method, the name of the class that that contains the code that should be called when a location update has transpired. So this is what we would see with an inner class in Window Builder when we right click and we say add a mouse listener. But we're not going to do inner classes here. We're going to explicitly name an object here, and that object has a method that will be called when a location update occurs. So I'm going to call this object just location listener. And here's my comment. So we're going to call some code inside loc listener when the location changes. All right, next thing I got to do is I got to define this object location listener. So let me go ahead and do that up here. So I'm going to make an object of type myll, that's short for location listener. And so I'll do that. All right. Well, now two things have happened. This has got to be resolved somehow because this class doesn't exist. But I also got a squiggly line under here. So this squiggly line is saying cannot resolve method. Request location updates, blah, 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 blah. Well, that's a different problem. All right, we'll come back to that one later. Let's resolve this first. So myll does not exist. I'm going to use this, come under more actions and say create class myll. So that's going to create a new file, myll.java. And here I'm going to say class myll, and I'm going to use this new keyword, implements. And this is going to implement a location listener. All right, so what does implements mean? It means that there is a description of a class called location listener. And inside location listener, there's a series of methods. And those methods don't contain any code. They're basically a blueprint for the code that I need to write inside this class. So let me go ahead and import location listener. And if I hover over this, I get the following message. Class myll must implement abstract method on location change parentheses location. So this is called an interface. And an interface is basically a description of a series of methods that you're required to write. So it's a little similar to extending a class, but instead of inheriting these methods, we're being told you have to write the following methods. This is their name, this is the type of arguments they take, this is what gets returned. And I'm getting an error here because one of the methods I have to create is called onLocationChanged. Takes an argument of location. And that is the method that's going to be called when our location gets updated. When the location is updated, it's going to look inside location listener for a method named onLocationChanged. All right, so what am I going to do? I'm just going to click on implement methods, and I'll implement all four of these, and now I've got, outlines for these four methods. My squiggly line message went away, but there's no code in here. But the deal is, this method is called when our location changes. And so I can say log.i, and we'll do test 31. And let's just print out our location by appending it to a string. And so we'll import the log class, and I spelled something, I got an underscore in there. Alright, so this will give us a log message when this method is called. So here's the setup now, right? We're saying, hey, here's a location manager. That's the thing that's managing, position information on the tablet. Hey, location manager, when you notice that the location has changed, go ahead and use the onLocationUpdate method inside this object loc_listener. And loc_listener is constructed, well, we need to construct loc_listener still. And that's going to be an object of type myll. So let's go ahead and do this. So let's make our loc_listener object. And then let's go ahead and call the onLocationChanged method inside that when the location changes. Alright, I got another red line to deal with. This says missing permissions required by LocManager.request location updates. I need to have access course location or access find location permissions. So this is another thing that's different from what we've done so far. Not every program can do the same things. And most of the apps that run under Android are running in some kind of sandbox. And they can interact, with their own memory space, and that's more or less it. If you want to do Wi-Fi stuff, if you want to access contacts, if you want to access hardware like GPS or accelerometer, if you want to access file system, you need permission to do that. And when you install an app and it says, this app needs the following permissions, what you're doing is you're granting permission so that this app can, get outside its sandbox and interact with other pieces of your device. And so this is warning us that, we need to make sure that we have these permissions. So I'm just going to say add permission. And what does that do? If we come back to our manifest, Android manifest.xml, this is the top level XML that sort of describes the entire application. There's a line here that just got added, which said we use permission access course location. And you can edit these files yourself, or you can use these mouse clicks to have code generated. So I'm just going to add access find location or dyn location. So now we've got two permissions that are available. This will let the application presumably access these location services. But we still have another detail to deal with, which is that it's possible the user has not granted these permissions. So this call requires permissions which may be rejected by the user. So it suggests adding some code to check to see if the permissions have been granted. So we can ignore that, or we can say add permission check. And if you're paid by the line of code, this is good stuff, because we just added 10 lines of code. So I'm just going to put a message here and say log.i test31 missing permissions. And the line of code that got added was if activity compatible, check self permission, access find location is not equal to granted. And check permission access course location is not equal to granted. Then it's going to go ahead and in this case just throw up a log message. But I'm going to give this thing permission, so it should be fine. Alright, so that's the end of our weird details. One more thing I'm going to do for this, and then we're going to run this and we're going to get out of here. In my location code, instead of just printing a location to a log message, I'm going to change this text field up here to showing my current location. And I'm going to show it in terms of latitude and longitude. So I want to access my message box object from inside here, but this is a separate class, right? So what am I going to do? Same thing we did in PA5 when we wanted to get to, say the J-frame from the net thread. We're going to pass a reference to the message box to this class. And so we can do that in the constructor, and we're going to do that as follows. When we make our myll object, let's just pass message box to it. So that our listener can write to message box. And so now let's go into our listener and let's make a text view message box. Let's import that. And let's make a constructor. So let's save this object for future output, and then let's go ahead on location changed. And let's print out our latitude and longitude. So location is the object passed to this, and it comes with a series of methods. One of them is get latitude. And the other is get longitude. I lost my plus sign. Message box. Dot set text. All right, we should be all set. So let's look at the setup one more time. When our application starts, we'll find our message box by using findView. We'll construct a location manager, or we'll access a location manager using getSystemService. We'll construct a location listener, which is our class, and pass the message box to it. We'll make sure we've got permissions, and if not, we'll print a log message saying, hey, you're missing permissions, and maybe I'll go ahead and put this in the message box also. Otherwise, we'll go ahead and we'll use the location manager to request updates, and we'll say here's the class that contains the methods you should call when the location is updated. And then in our location listener, when we construct, we'll save the message box. When the location changes, we'll use the message box to display latitude and longitude. And that should be fine. So let me do this without giving permissions first. Let me go ahead and run this. There's a reasonable chance this is going to work. Alright, so it said missing permissions, and if I look at my logcat file, there should be a message in here also saying, missing permissions. So we have to give this application permission to access location services. And you can set this up to ask for permissions when it first runs. I haven't done that. So I'm just going to go into my settings and my applications. And this should show up under recent applications. And I'll go to permissions, and permissions it says denied location. By default, it's not going to grant permission. Allowed, no permissions allowed. So I'm going to click on this, and I'm going to say allow location access. And now that's allowed. And so let's go ahead and run test 31 once more. And let's see. Oh, I need to actually shut it out. All right, let's run test 31. And hey, there's our latitude and longitude. And if I pick this up and I walk around, those will change slightly. So there you go, right? It took a while, but again, the actual amount of code we ended up writing was pretty minimal, right? It's one class, which we could have done with an inner class if we wanted, but it's really just one class with one method on location change, and when the location changes, we get called with this object that has, latitude, longitude, and a bunch of other information inside it. And then we just had to set ourselves up as a listener by saying request location updates. And then details like permissions and so on and so forth. So this is how you can get into the accelerometers. This is how you can start getting into some of the messaging capabilities and so on and so forth. But you got to read the documentation. You gotta go back through the API documentation or find some examples and so on and so forth. And like I said, it's a moving target. Smartphones are a relatively new creation as of 20, 30 years ago, and best practices change over time. So for example, if you want to do socketed communication, let's say you wanted to hit a button and open up a socketed connection to a server and play dots or something, right? The way Android is set up right now, you cannot run network code from inside this method, right? You have to do your networking stuff from a separate thread. It's a safety thing to make sure that your application doesn't hang while it's waiting to have a connection request accepted and so on and so forth. And so it's a rule since version something of Android, all your network stuff has to go in a separate thread. So if you had an app that you wrote before that and it worked great, and now you try to run it on a newer version of Android, it's not going to work because the stuff changes over time. But if you got some time and you want to sit down and spend a week digging into this stuff, usually it changes slowly enough that it's not going to change from one day to the next. I got lucky between Sunday night and Monday morning that things updated. But so this is another thing that you can do with what you've been doing in class and what else you might know from elsewhere. It's Java. It lets you tap into hardware. It lets you work with kind of real world situations, and all of that is pretty fun. All right, so not on the test, but for what it's worth, there you go. There's some 40,000 foot views of Android app development. All right, any questions, comments? Thoughts, reactions?
It's shifting all over the place on multiple other development platforms too. Like, I was just talking to my dad the other day because I went to go pick up a new phone, and I was like, I wanted to get started on some iOS development, and on the .NET side of things, they're deprecating Xamarin for Maui, like right now.
Mm-hmm.
All of that stuff is changing, and the interesting thing there is they're taking an approach to making it work on any platform, including PC, iOS, Android, and all that stuff, and that's pretty cool.
Interesting,
yeah. Platforms are just going for PC and everything really.
Mm-hmm. Definitely. Yeah. So stuff changes, stuff gets deprecated. This is one of the challenges if you're trying to support some application that you've developed. You're going to put it out there, make it available for people. It's kind of a full-time job because every time that the underlying system updates, you potentially have to change your code. If you wrote this for Android and then you wanted to port it to iOS, it's different code. It's a different API. It's an entirely different development environment. It's not like you can just take this and recompile it and you're done, right? It's really a separate process. And so this is part of the challenge. This is why some really great apps that you find on one type of phone aren't available on others. They've got to be supported. This is why Linux is missing some really cool software that runs on Windows. Similar idea.
That's starting to change a little bit with Vulkan.
It's starting to change. I kind of think the profit mindset will always keep at least two main versions of whatever, whether it's Windows, Linux, or Coke and Pepsi, or Winston and Marlboro, or whatever. I think that's with us as long as we have our current version of society.
I think open source is still going to be the slow and steady wins the race for Vulkan and things like Godot and Blender. They're all starting to be industry standard in a lot of ways.
I don't think you can beat open source. I mean, it's just common sense, there's no way a team of developers can do as good a job as, you know, the entire user community. They're not invested in it, and their resources are limited. And I mean, this is part of why I went open source on all of my stuff years ago, because it's like I've only got, you know, a few more decades left, and other people are going to be able to do a lot more with my stuff than I can ever, you know, imagine doing at this point. And I think that's always going to win out in the end. And you can make money on open source software. It doesn't mean it's non-profit. It's just a different mindset. And I think that's super exciting.
Yeah, I'm trying to move away from closed source too.
Yeah.
Been trying to get this dual boot working for days.
Oh no. I like the idea of dual boot. I gave up on it a long time ago. But theoretically, it's a good solution. Inevitably, something steps on something, it seems.
I've been running into this interesting problem of it looks like my drive is broken after I install it and run it once and update.
Fun.
It's like read pdmaq, and it doesn't matter what kernel I use. It happens on all
Interesting.
4 of them that I tried.
Yeah. Yeah, I'm getting nervous these days because my Bluetooth keeps going out, and I got some boot warnings a few days ago, and I'm getting worried that, like, I mean, I should be able to make it to the end of the quarter, but I don't know what's going to happen over summer. I might be doing a big upgrade at some point. All right, well, we have SLP starting at 3 o'clock, so I will let people out. Right now, that gives you about 10-12 minutes to stretch your legs and such. And on Canvas, there's a Zoom link for the SLP presentation, so go ahead and follow that. Izad's probably already there. There should be a table when you get in showing the names of the people attending and what room you're going to be in, or you can ask Izad or I for help, and we can move you into a room. And then, you know, just kind of hang out, round robin with the other people in the room. Talk about your projects, and have fun with this, right? It's at some level fun for most people to talk about themselves, talk about what they've been doing. And I know people have been doing some really amazing things in their SLPs, even if you feel like you didn't get where you wanted to, or, you know, you didn't really do a lot of work on it until the last few weeks or something like that. Just go ahead and tout what you've done. And there's great benefit in being able to talk, you know, not making up things or lying, but being able to talk about what you have done, and putting it in a good light, putting it in terms of the successes and the positive outcomes and achievements that you've gotten, instead of, oh, I wanted to do this, but I really only just did this other thing. So, you know, friendly crowds and interested people, and the security of, you know, being in Zoom behind a camera. So hopefully people have a good time with it. And we'll talk about that a little on Thursday, and then Thursday we'll mostly just do wrap-ups. So that's pretty much all I got for new material. So I'll leave it there, and I'll see people in a few minutes in the SLP presentations. Again, look on Canvas for the Zoom information. All right, thank you, everybody. Have a fantastic time. Talk to you later.
See you later.
Thanks.
Thank you.